Swayam Prabha. Digital India. Educated India.
Welcome to this course on transition metal organometallics in catalysis and biology. In continuing with our earlier discussion, we would be looking at examples of ring closing in ion metathesis reaction. In short, these reactions are called RCEYM, ring closing in ion metathesis reaction, and then we will try to finish up all the related examples with regard to this particular reaction, and then if we have time, we are going to start another new topic, another new interesting reactions, which are alkene and alkyne oligomerization reactions. Now, in keeping with the theme of this course, which was intended to highlight all the industrial scale applications of organometallic reactions and catalysis in particular, this alkene and alkyne oligomerization reaction is another Nobel Prize award winning discovery that we are going to take up next after olefin metathesis, which was also awarded a Nobel Prize. So, now we go back to our discussion on ring closing in ion metathesis reaction. We have looked into several examples in the earlier lecture about ring closing in ion metathesis reaction. What we have in a gist what we have learned so far is that ring closing in ion metathesis reaction is a intramolecular reaction where the substrate happens to have both the olefin as well as the alkyne bond. In short, ring closing in ion metathesis or ring this reaction. This reaction, what we have learned in short is that the substrate has both the alkene and the alkyne components, and the reaction is intramolecular. Molecular metathesis reaction, and hence the preferred mode of reaction is that it is preferred under high dilution conditions in order to suppress intermolecular cross metathesis reactions. And these cross metathesis reactions may occur between the alkynes, two of these molecules alkynes. So, it can be alkyne cross metathesis, intermolecular cross metathesis, or even alkene intermolecular cross metathesis, and this is pretty much suppressed by performing this RCEYM reaction under high dilution conditions. And the last thing is these are important properties that we have been learning about this RCEYM. First is that this is the intramolecular reaction preferred under high dilute conditions and suppresses the cross metathesis reaction. The second thing is that the favorable pathway or preferred pathway involves involves in first mechanism, which means that the active species is formed on the olefin first and the active species is the metal carbene species as is shown over here, and that further reacts with the alkyne subsequently. This reacts with the alkyne subsequently to give the corresponding RCEYM product, and this is the active species for this ring closing in ion metathesis reaction. So, this is exactly a few points that we take home from our discussion on ring closing in ion metathesis reaction. In this regard, we have looked into other possibilities. For example, we had looked into the possibility of reaction happening in the alkyne or at this site, alkyne site, giving the active species, but and that mechanism is called ion first mechanism. But we have also noted that the ion first possibility will have lot of regioisomers. So, there is a lack of regioselectivity, whereas these reactions as observed are highly selective, which sort of points to the in first mechanism. So, in this context we have discovered we have discussed various other possibilities which have been proposed, but have not gained popularity with regard to the mechanism, the active species, as well as the conditions in which these reactions are carried out. Now, continuing with our discussion on ring closing in ion metathesis, today we are going to look at two more examples of RCEYM reaction, but they are taken in a context of more complex maneuver with regard to organic synthesis, particularly tandem reactions which involves RCEYM along with other reaction. For example, it can might as well be a cycloaddition or other reactions which in tandem with RCEYM some complex substrate has been obtained. So, let us start with these examples that I have been referring to. So, in this let us take a look at this example of tandem RECYM in which there is a cycloaddition reaction proceeding along with the ring closing metathesis reaction. Examples: the one that we would be referring to have been used for synthesizing highly substituted bicyclic compound octahydrobenzo C azapine 3-one. So, this is given as in over here. The reaction is shown over here. R1 and after several maneuver the final product is this compound and this complex synthesis was reported by Blakert in 1999. This synthesis very nice way of making this complex molecule involved using these two strategies, one say RC ring closing RC involve this ring closing RC in metathesis reaction. This involves ring closing in metathesis reaction. This complex example was synthesized using this ring closing in metathesis along with attendant cycloaddition reaction. So, we are going to take a look at the mechanism for this formation as is given below. This involved first the reaction of the substrate some polymer support this reacting with Cl2 Cl2 and the reaction would proceed as is shown here. As is shown here, and then this would give the product as is shown here. Now, this is not the active species, which this is the active species, but will not propagate. So, then the reaction would proceed, the one which would be necessary would be the one that would proceed along the other conformation. Please note please note the conformation over here, as over here they are just the reverse. Now, this would then react further to give and now that would rearrange to give the product So, this the point to note is that of these two possibility, this is the correct pathway that gave the active species on this substrate. So, the next step thus involves the reaction of this substrate for with further the product, and this is shown in the next slide. Now, this substrate would then react with the alkyne substrate, which is R1 to give as is shown here. Now, this would subsequently undergo rearrangement as is shown here. So, double bond between 4 and 5 R1. Now, this then would react with olefin to give the corresponding metathesis product. Along with the elimination of Cr2, the active species. So, once this is formed, then this is reacted with methyl aluminum dichloride in presence of this alpha beta unsaturated carbonyl compound R2. So, a cycloaddition reaction follows suit as is shown over here. and the reaction proceeds to give this product which then is reacted with amine in t-butyl NH4 reagent to give this amide NHR3, and finally, this cyclization with trimethyl aluminum and triethylamine. Cyclization involves this reaction with this amine over here to and followed by detachment from the ring. Give the desired product as is shown here. NR3 R2 R1 in 20% yield. Now, this is a very interesting reaction, and even though the yield 20% seems low, but in the context of such a complex molecule, 7 membered, 6 membered bicyclic amide of functional compound. So, such a complex molecule being formed in a multiple sequence tandem step sort of speaks well about this yield of even 20%, which otherwise may seem very low, but this is not trivial in this particular case, because such a complex molecule has been formed. Now, another important highlight of this reaction is that it undergoes this in-ion metathesis reaction, ring closing in ion metathesis reaction. So, this reaction happens in the first half, and then this cyclo addition reaction which happens resulting in the formation of the 6 membered ring, and that shows the beauty of this reaction. So, to put this two reactions which has happened, they are more appropriately they are called in-ion metathesis, not the ring closing, because the two substrates are not the alkene and the alkyne moiety are on two different substrates. So, this is intermolecular in-ion mechanism metathesis reaction. So, this is the intermolecular reactions, and then as the alkene and alkyne are on two different substrates. So, with this we come to an end of today's discussion, where we have taken up an example and worked it out, showing the different orientation in which the metal carbene species may react with the substrate. And what we have seen is tandem reactions of cycloaddition as well as enine metathesis with regard to the earlier discussion on ring closing enine metathesis reaction, and how these active species leads to a very complex product which is shown over here even in 20% yield. So, with that we come to conclusion of today's lecture, where we have seen a tandem reaction as it proceeded by this enine metathesis and cycloaddition reaction. We are going to take up a bit more detail another example, interesting example of this enine metathesis reaction when we meet next on this lecture series. Till then, goodbye and thank you.